It is given to us that dh dt is equal to 1 over 10 square root of 16 minus half h, which is also 1 over 10 of 16 minus half h to the power of half. I'm going to try to solve this differential equation, and what we have here is a form of a variable separable. According to what we have discussed in the topic outline, this portion here I'm going to shift it over to the left hand side, which will give me a 10 of 16 minus half h to the power of minus half of dh dt is equal to 1. And if I were to integrate both the left and right hand side with respect to t, it is going to be integration of 10 of 16 minus half h to the power of minus half dh on the left hand side, and on the right hand side will just be an integration of t. And for this, if I were to integrate, it is going to be 10 of 16 minus half h to the power of minus half plus 1, it is half, divided by the coefficient of h minus half, and the power, which is half, plus arbitrary constant, and this is just t. Which means that t over here is going to be equal to minus 40 square root of 16 minus half h plus a. It is given to me by the question when t is equal to 0, h is equal to 0. So I'm going to make use of that as my boundary condition. So if I were to substitute the values in, that means minus 40 square root of 16 minus 0 plus a is equal to 0. This will help me to solve for a. A is going to be equal to 160. That is why now I know what is the full expression for t. It is minus 40 square root of 16 minus half h plus a, which is 160. We are also supposed to find the time that the tree is going to take for it to reach half of its maximum height. The maximum height is 32 according to what we have discussed in the previous part of the question. So I'm going to let h be equal to half of 32, which means that the time that is going to be taken is minus 40 square root of 16 minus half of 16 plus 160. So the time that is going to be taken is going to be 46.9 years.